The relationship between the Kp value and Kc value. Consider a general chemical equilibrium reaction in which the reactants and products are in gaseous state. Here is the reactants and here is the products. So over here Kp is equal to PLL PMM. This is how the equation, where P is the partial pressure of the respective cases in terms of molar concentration of reactants and products. We got Kc here. This is how the equation is. For any gaseous component I, in a mixture its partial pressure Pi is related to molar concentration Ci, as Ca is equal to Pi divided by Rt. Since Pa is equal to Ni divided by V into Rt, where Ni divided by V is equal to Ci, is the number of moles of I per liter and V is the volume in liter. And Ca is called molar concentration and Pa is the partial pressure. So substituting the concentration terms by partial pressure, this is how I got the equation. So taking out the 1 by RT, everything out, you got this equation, which indicates a Kp divided by RT power Ng, delta Ng, and indicates Kp is equal to Kc into RT into delta Ng, where delta Ng is equal to total number of stoichiometric moles of gaseous products minus the total number of stoichiometric moles of gaseous reactants. So product minus reactant, simple. That's delta Ng. Usually, depending upon the sign of delta Ng, Kp and Kc will be relating three things. Delta Ng as 0, positive and negative. Let's move on to the first one, equal to 0. The total number of moles of gaseous products are equal to the total number of moles of the gaseous reactants. Here is the example of the formation equilibrium of hydrogen iodide. Over here number of molecule is 2 minus 1 plus 1, which is equal to 0. That's delta Ng. So Kp is equal to Kc into Rt power 0. Case 2, where delta Ng is positive. The total number of the moles of gaseous products are greater than the total number of moles of the gaseous reactants. So water plus chlorine will give hydrochloric acid and O2, oxygen. So delta Ng is equal to 4 plus 1 minus 2 plus 2. So 5 minus 4 is 1. So Kp is equal to Kc into Rt power 1. Indicates Kp is greater than Kc. Structure of ammonia. So ammonia, it won't react with other chemicals, and there should be something which is really important to impress it. This can be appeared or this can be achieved via the catalyst at a very high temperature. And now you got the ammonia. So it's NH3, so nitrogen and hydrogen, it's mixed up to form the ammonia, and here is the typical design of ammonia reactor. Ammonia is really an important one for the manufacturing of fertilizers. Fertilizers are really important for the growth of plants. So here is the reactor. Using that you will be constructing and preparing the fertilizers. As indicated, you got the nitrogen and it's mixed up with the hydrogen to form ammonia. And the ammonia is cleaned up and it is filtered and it is formatted. So amending of carbon monoxide, carbon dioxide, oxygen and hydrogen into the ammonia to make it a necessary fertilizer. So it will be treated in water to materialize it further. You are able to see everything is condensed. This is how ammonia is constructed or its fertilizer is prepared. Here is case 3 where delta Ng is negative. The total number of moles of the gaseous products are lesser than the total number of moles of the gaseous reactants. Over here 2 minus of 3 plus 1. 2 minus 4 is minus 2. So Kp is equal to Kc into Rt power minus 2. That's Kp equal to Kc divided by Rt square.